Hello and welcome to lesson 4.3. Today we're going to look at solving inequalities by multiplication and division. When we solve inequalities with multiplication and division, it's actually very similar to what we were doing when we were solving equations with multiplication and divisions. There's only one thing that we have to really pay attention to. Okay, so first and foremost, if you're multiplying by a positive number, then we are going to leave our symbol the same. Okay, and by symbol, I mean our inequality symbol. Okay, so the inequality is going to stay the same. However, if we're multiplying by a negative number, then the direction of the inequality must be reversed. Okay, this is very critical. And a way you can always double check your work is to pick a test point and double check that our inequality makes sense. Okay, so let's go ahead and look at a few examples. So for this example, it says solve x divided by 2 is less than -1. So if I go ahead and I want to get x by itself, because my directions say to solve, I'm going to have to multiply both sides by 2 so I can clear out that denominator, and that's going to leave me with x and -2. And because in this case, I multiplied by a positive 2 here, I'm going to leave my inequality symbol alone, and it's going to go in the same direction. So in this case, I have x is less than -2. Now earlier, I mentioned something about picking a test point. I like to pick the test point, and I'm going to write TP equals 0. Okay, because 0 is an easy one to use if we can. So if I plug a test point of 0 in for x, let me change the color here. Okay, and I write 0, is 0 truly less than -2? If it is, that tells me that my inequality is facing the correct direction. So I know that x is less than -2 is my correct answer. When we divide inequalities, okay, it's the exact same rules as multiplication. So it says if we're dividing by a positive number, then our inequality is going to stay the same. However, if we divide by a negative number, then we have to reverse that inequality. And just kind of remember that division by 0 is still considered undefined, and we can't do that. So let's look at another example and see how this works. So example 2 says to solve -4c is less than 24. Again, I'm solving, which means I need to get my variable by itself. So in this case, I have -4 times c, which means I have to undo that multiplication with a division of -4 on both sides. My -4's are going to cancel, and I'm going to be left with c, and then 24 divided by -4 will give me a -6. Now, on the previous slide and on the second slide, we talked about if we divide or multiply by a negative number, which in this case, I just had a -4, so I divided by that -4, I have to reverse my inequality, okay? And I'm going to pick a test point just to prove out why. So again, if my test point is equal to 0, if I plug in 0 for c, I get 0 is greater than -6. And on a number line, okay, 0's up here, -6 will be over here. 0 is in fact greater than -6. This tells me that c truly is greater than -6. But just off to the side here, let's pretend that we had forgotten to reverse our inequality. So let's say you left that as c is less than -6. If I would have used my test point and I would have plugged a 0 in for c, I would have had 0 is less than -6. This is not true. 0 is not less than -6, so that needs to be an indicator that something is wrong. So I would probably suggest that you go back and say, oh, I did divide by a negative number. That means I need to reverse my inequality so that this is in fact incorrect. Okay, and the same thing will hold true if we multiplied by a negative number. If we multiply by a negative number, you also have to reverse that inequality symbol as well. Now example 3 says, the student council votes to buy food for a local food bank. A case of 12 jars of spaghetti costs $13.75, and it wants to know what is the greatest number of cases of sauce the student council can buy if they use at most $216 for this project. So in this case, my price is $13.75 per case. So I'm going to have to multiply that to figure out the cost. So if I have $13.75 for each case, I'm going to have to multiply that by the number of cases C to find out what my total cost is. Well, they tell me that I can't spend any more than $216. So I have $216 to spend, and I know that the cost of my cases has to be less than or equal to that $216, because we cannot exceed $216, but we can spend $216 if we have to. So I can go ahead and include that. So now in order to figure out how many cases we can buy, I'm going to divide both sides by $13.75. And I see that we have cases are going to be less than or equal to, when you divide $216 by $13.75, you do get 15.71, we'll say. So ultimately in this situation, it says what is the greatest number of cases that can be purchased? Okay, we can purchase 15 cases of sauce. Okay, because the 0.71, I can't purchase 70% of a case. So at most I can purchase is 15 cases for this local food bank. Example 4 says an elevator like the one at the left, which I forgot to attach a picture, I apologize, will safely lift at most 4,400 pounds. A concrete block has an average weight of 42 pounds. What is the maximum number of concrete blocks that the elevator can lift? So here we know that our max total is 4,400 pounds. So I have 4,400 pounds. And we are told that a concrete block has an average weight of 42 pounds. What is the maximum number of blocks that we can lift? So we're going to have 42 pounds for each block, and we're going to multiply that by the number of blocks that we have, and this has to be under that 4,400 pounds. So it's going to be less than or equal to 4,400, because we can lift, the lift can lift the 4,400 pounds, but it shouldn't lift more than that. So now what we're going to do is we're going to go ahead and divide both sides by B, or the 42, to get B by itself. And this is going to leave me with B is less than or equal to 104.76. And because the question said, what is the maximum number of concrete blocks? It really means that the lift can hold 104 blocks to fall within the safety specs. And our last example says a friend calls you and asks you to meet at a location 3 miles from your home in 20 minutes. You set off on your bicycle after the telephone call. Write and solve an inequality to find the average rate in miles per minute you could ride to be at your meeting place within 20 minutes. So using our distance equals rate times time equation, okay, we're ultimately trying to find the rate. So if I want to find the rate, I need to isolate that. So I'm going to divide both sides by my time. And this is going to leave me with my rate being equal to my distance divided by my time. Now in this sense, I have to think about the inequality portion of it. Okay, I want to meet my friend within 20 minutes. So I know that if I ride faster, I'm going to get there sooner. If I ride slower, I'll get there after my 20 minutes. So when I set up my actual inequality, my rate then has to be greater than or equal to my distance over my time, because I want it to, if I get there earlier because I'm going faster, then I'm okay with that. But what I don't want to happen is I don't want to be late. So I don't want that to be less than this rate. So now all I'm going to do is I'm going to plug in what I know. So I have my rate is greater than or equal to my distance of 3 miles divided by my time of 20 minutes. So when I divide 3 miles by 20 minutes, I end up with a rate of 0.15, and my units are miles per minute. And that's exactly what it said I could have it be in right here. So we have to go a minimum of 0.15 miles per minute in order to make it on time. I can go faster, I just can't go slower than that. Please let me know if you have any questions. Otherwise, I hope you have a great day, and I will see you in class.